It is a common and often standard practice to connect the fire suppression system to the required emergency power off, often referenced as EPO. This connection is frequently addressed in the National Electrical Code, specifically Section 645.10. Several key reasons underscore this practice. Firstly, safety is paramount. The main objective is to safeguard both personnel and equipment located within the server room or data center. Connecting the fire suppression system to the EPO mechanism ensures that, upon activation of the fire suppression system, power to all equipment is immediately disconnected. This rapid power disconnection is crucial in preventing a range of electrical hazards, including electric shocks, arc flash events, and the potential for further escalating damage resulting from the fire. Secondly, adhering to code compliance is essential. Many jurisdictions, along with various industry standards, mandate the integration of fire suppression systems with EPO systems within server rooms and similar critical environments. These requirements are often explicitly detailed in local building codes and fire safety regulations. By ensuring compliance with these established standards, organizations can demonstrate their commitment to safety and minimize the risk of potential legal repercussions or insurance-related challenges. Thirdly, equipment protection plays a vital role. Beyond the immediate concerns of safety, disconnecting electrical power to equipment during a fire event is instrumental in protecting sensitive and often expensive electronic devices from substantial damage. By promptly cutting off power, the risk of electrical surges or short circuits caused by the fire is significantly reduced, helping to preserve the integrity and functionality of essential servers, data storage systems, and network infrastructure. Fourthly, insurance mitigation can offer financial benefits. Certain insurance policies may provide reduced premiums or enhanced coverage options for businesses that proactively implement additional safety measures, such as integrating fire suppression systems with EPO systems. By demonstrating a commitment to protecting both equipment and personnel through such measures, organizations can potentially lower their overall insurance costs. However, it is important to acknowledge that specific circumstances or exceptions may exist where directly connecting the fire suppression system to the EPO system may not be deemed feasible or necessary. In such instances, seeking expert guidance from qualified professionals is crucial. It is recommended to consult with a licensed electrician, a fire safety professional with expertise in suppression systems, or the local authority having jurisdiction, known as the HC. These experts can conduct a thorough assessment of the specific situation and provide informed recommendations on the most appropriate course of action to ensure safety and compliance. The Emergency Power Off System, or EPO, serves as a critical safety mechanism designed to rapidly energize electrical circuits within a data center or server room environment during emergency situations. These situations can include, but are not limited to, fire events, electrical incidents, or other scenarios that pose an immediate threat to personnel or equipment. The primary purpose of an EPO system is to mitigate potential hazards and minimize damage by promptly cutting off the electrical supply to equipment and systems that could exacerbate the emergency or pose a risk to individuals. Understanding how EPO systems work is essential for ensuring their effectiveness and proper implementation. Typically, an EPO system consists of several key components including emergency shut-off switches, control panels, and circuit breakers. Emergency shut-off switches are strategically located throughout the facility, providing personnel with readily accessible points to initiate the EPO sequence. These switches are often brightly colored and clearly labeled for easy identification during emergencies. The control panel serves as the central hub of the EPO system, monitoring the status of the emergency shut-off switches and initiating the shutdown sequence when an emergency is detected. The control panel is typically equipped with indicators to show the status of the system, such as whether it is armed, disarmed, or in an emergency shutdown mode. Circuit breakers are used to disconnect the electrical power supply to the various circuits and equipment within the data center or server room. When the EPO system is activated, the control panel sends a signal to the circuit breakers, causing them to trip and interrupt the flow of electricity. To ensure reliable operation, EPO systems often incorporate redundant power supplies and backup batteries. This redundancy ensures that the system can continue to function even in the event of a power outage or failure of the primary power source. Additionally, EPO systems may be integrated with other building systems such as fire alarm systems and building management systems to provide a coordinated response to emergencies. When a fire alarm is triggered, for example, the EPO system can automatically initiate a shutdown sequence to de-energize electrical circuits and prevent further damage. The National Electrical Code, or NEC, provides guidelines and requirements for the installation and operation of EPO systems in data centers and server rooms. Section 645.10 of the NEC specifically addresses the requirements for emergency power-off controls for information technology equipment. According to the NEC, EPO switches must be readily accessible and clearly identified. They should be located at the main exit doors of the data center or server room, as well as at other strategic locations within the facility. The NEC also requires that the EPO system be designed to prevent accidental or inadvertent operation. This can be achieved through the use of recess switches, key-operated switches, or other protective measures. In addition, the NEC mandates that the EPO system be tested regularly to ensure proper operation. These tests should be conducted in accordance with the manufacturer's instructions and any applicable local codes or regulations. In the event of a fire, the activation of the fire suppression system and the EPO system can help to minimize damage and protect lives. When a fire is detected, the fire suppression system is activated, releasing fire extinguishing agents such as FN200 or carbon dioxide. Simultaneously, the EPO system is activated, cutting off the electrical supply to the equipment in the data center or server room. By removing the electrical power source, the EPO system can help to prevent electrical fires from spreading and causing further damage. It can also help to protect firefighters and other emergency responders from electrical hazards. In addition to the NEC, other industry standards and best practices provide guidance on the design, installation, and operation of EPO systems. These standards include those published by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the Telecommunications Industry Association, or TIE. These standards provide detailed recommendations on topics such as EPO system design, component selection, testing, and maintenance. Following these standards can help to ensure that the EPO system is reliable, effective, and compliant with industry best practices. When designing and implementing an EPO system, it is important to consider the specific needs and requirements of the data center or server room. Factors to consider include the size and layout of the facility, the type and amount of equipment installed, and the potential hazards present. It is also important to consult with qualified professionals such as electrical engineers, fire protection engineers, and code officials to ensure that the EPO system is properly designed and installed. Regular maintenance and testing are essential for ensuring the continued reliability and effectiveness of the EPO system. Maintenance tasks may include inspecting and testing the emergency shut-off switches, control panels, and circuit breakers. It is also important to verify the operation of the redundant power supplies and backup batteries. Testing should be conducted in accordance with the manufacturer's instructions and any applicable local codes or regulations. Any deficiencies or problems identified during maintenance or testing should be promptly addressed to ensure that the EPO system is ready to respond in the event of an emergency. Connecting the fire suppression system to the EPO is a crucial safety measure that can help to protect lives and equipment in the event of a fire. The EPO system serves as a critical safety mechanism designed to rapidly de-energize electrical circuits within a data center or server room environment during emergency situations. It is important to understand how EPO systems work, comply with the requirements of the National Electrical Code, and follow industry standards and best practices. Regular maintenance and testing are essential for ensuring the continued reliability and effectiveness of the EPO system. By taking these steps, organizations can help to create a safe and secure environment for their employees and equipment. Consider a scenario where a fire ignites within a server rack in a data center. The heat and smoke trigger the fire suppression system, which begins releasing a specialized extinguishing agent into the room. Simultaneously, the connection between the fire suppression system and the EPO activates, immediately cutting off power to the affected server rack and surrounding equipment. This swift action prevents the fire from spreading rapidly through electrical pathways, potentially saving the entire data center from catastrophic damage. Now consider a different scenario. An electrical fault occurs within a server, causing sparks and flames to erupt. Without the fire suppression system linked to the EPO, the electrical current continues to flow, feeding the fire and allowing it to intensify. The flames spread quickly, engulfing nearby equipment and posing a significant threat to personnel attempting to extinguish the blaze. In this case, the absence of a connected EPO system exacerbates the danger and increases the potential for extensive damage and injury. The rationale behind connecting the fire suppression system to the EPO is multifaceted. Firstly, it safeguards human life. In the event of a fire, electrical hazards such as exposed wires, energized equipment, and arcing can pose immediate threats to individuals in the vicinity. By automatically de-energizing the affected area, the EPO minimizes the risk of electrical shock, electrocution, and other fire-related injuries. Secondly, it protects valuable equipment. Data centers and server rooms house a vast array of expensive and sensitive electronic equipment. Fires can cause irreparable damage to servers, storage devices, network infrastructure, and other critical components, resulting in significant financial losses. By quickly cutting off power, the EPO can prevent electrical surges, short circuits, and other fire-related damage, preserving the functionality and lifespan of valuable assets. Thirdly, it minimizes downtime. Fires can disrupt operations and cause prolonged downtime for businesses. The cost of downtime can be substantial, encompassing lost revenue, decreased productivity, and reputational damage. By swiftly extinguishing the fire and preventing further damage, the EPO helps to minimize downtime and facilitate a faster recovery. Fourthly, it ensures regulatory compliance. Many jurisdictions and regulatory bodies mandate the connection of fire suppression systems to EPO in data centers and server rooms. Compliance with these regulations is essential to avoid penalties, fines, and other legal consequences. Furthermore, insurance companies may require such connections as a condition of coverage. The connection between the fire suppression system and the EPO is typically achieved through a dedicated control panel or interface module. This device monitors the status of the fire suppression system and, upon activation, sends a signal to the EPO to initiate the power shutdown sequence. The control panel may also incorporate manual override switches, allowing personnel to manually activate or deactivate the EPO if necessary. The design and implementation of the connection between the fire suppression system and the EPO should adhere to relevant standards and best practices. These standards provide guidance in the selection of appropriate components, wiring methods, and installation procedures. It is important to consult with qualified professionals, such as electrical engineers and fire protection engineers, to ensure that the system is properly designed and installed. Regular testing and maintenance are essential to verify the functionality and reliability of the connection between the fire suppression system and the EPO. Testing should be conducted periodically to ensure that the EPO activates correctly upon activation of the fire suppression system. Maintenance should include inspecting wiring connections, verifying the operation of control panels and interface modules, and replacing any worn or damaged components. Despite the numerous benefits of connecting the fire suppression system to the EPO, there may be certain situations where this connection is not feasible or desirable. For example, in some older facilities, the existing electrical infrastructure may not be compatible with the installation of an EPO system. Additionally, in certain critical applications, it may be necessary to maintain power to certain equipment even during a fire event. In these situations, alternative measures should be implemented to mitigate the risks associated with fire. These measures may include installing fire-resistant enclosures around critical equipment, providing redundant power supplies, and implementing enhanced fire detection and suppression systems. It is important to carefully evaluate the risks and benefits of connecting the fire suppression system to the EPO in each specific situation. The decision should be based on a thorough risk assessment, taking into account factors such as the type and quantity of equipment in the facility, the potential hazards present, and the applicable regulatory requirements. In conclusion, connecting the fire suppression system to the EPO is a standard practice that offers numerous benefits, including protecting human life, protecting valuable equipment, minimizing downtime, and ensuring regulatory compliance. While there may be certain situations where this connection is not feasible or desirable, alternative measures should be implemented to mitigate the risks associated with fire. The design, implementation, and maintenance of the connection between the fire suppression system and the EPO should adhere to relevant standards and best practices.